In this video, we'll review operator overloading in C++. Before we get to that, we'll also discuss a brief review of classes and const functions and the const keyword. First, let's review parts of a class. So, as an example, we have a grocery list class, and this grocery list class is basically an example of how we could write our own dynamically sized array. It has 3 data members. It has size t's for the number of items that are on our list, the list size, the entire size of which we could store, the capacity you can think of it, and we also have a unique pointer to an array of strings on the heap. And that is what we're calling list, and that is essentially where we're going to store the items that are going to be represented on our grocery list. Now, we have 2 constructors. One's the default constructor, and the second is a size t that just initializes the size of the array strings that we're going to keep on the heap, which is essentially the capacity. We also have several other member functions. So we have member functions such as add item, remove item, merge, get item, print the list, empty, and the size. And we also have the destructor to clean up after we have used any resources, in particular memory on the heap, and we'll talk about what happens with that. Now, in order to review the use of unique pointers, I want to talk about how we can actually double the size of our array of strings on the heap. So in this specific example, we can also talk about how we can call member functions. So you can see in main, we instantiate a grocery list, L1. When we have an instance of an object or a reference to an instance of an object, we can use the dot operator. If we have a pointer to an object, we need to use the arrow operator. So in main, we call L1.addItem, and we're going to add bananas to our list. The other thing I want to remind you is that when we have unique pointers that are to arrays on the heap, we can use the subscript or the square bracket operator. So let's see what add item actually does. So add item is given a string of an item that we want to add to our lists. It first checks if there is any space left in the list. And if there's no space left, it's going to double the size of the array where we store our grocery list on the heap. Otherwise, it's just going to store the string for the item we want to add in the last available position in the list array and increment our number of items that we're keeping in our list. Now, double list is where we actually deal with our dynamic memory on the heap, our array of strings where we're keeping our list. So the first thing you'll notice is that we declare a unique pointer to an array of strings called old list. And when we declare it, we initialize it with the address of the array of strings on the heap that's too small. That's what we're doing with list.release. You can also use move to initialize our old list also. After we've transferred the address of the array of strings that's too small, we have to update our data member that's keeping track of our array of strings on the heap that is the appropriate size. And to do this, we call makeUnique, and we pass the type to be the array of strings, and we double the size. So we say list size times 2. So what makeUnique does is 2 things. It creates an array of strings on the heap dynamically of size list size times 2. And it makes sure that list, the data member unique pointer, keeps track of the address of the memory of the appropriate size array of strings. Then we just copy over the old items to the new list and update the size data member of our grocery list. So it's just a quick review of unique pointers. Now let's get into const keyword. Now, you may have noticed that several of the member functions have the const keyword after them. So the examples that we had were get item, print list, empty, size. And all that means is that those member functions will not change the object for which they are member functions. So just to see the quick implementation, when we implement size, it just returns the number of items that are currently on our list. And by just returning a size T, it's not actually changing any of the private data of the grocery list. So just to see this concretely, inside main, we instantiate a grocery list called L1, and then we call size on the instance L1, and we save the size T. And when we do this, all we do is we just save the current size, and there are no changes to the L1 object. So that's what const means. So when you have a const member function, you will not change the instance for which that member function is called. Now, you may have noticed that we not only had the const keyword after the member function, we had it before a return value. So for get item, it takes as its only parameter the position of an item in the list, and it returns a const reference to string. And what the const means for a return value is that the string, the reference to the string that is returned by get item will not be changed. It cannot be changed. So in particular, if we look at our implementation of get item, I leave as an exercise for you to add appropriate error checking for that we had entered a valid position as an argument, but given that, all we're going to do is return the string in the list at the position given. And so that's the, we return a reference to that string. Okay, what does that mean when we actually call this function? So two objects cannot be changed in main. So we declare our grocery list again, which is L1. So that's an instance of a grocery list. And then we add the item to the list, bananas. And then we want to get the string at position 0. So get item 0. There's two ways that are valid for us to actually access this string. One way is to make a copy. So you can see in our first call, this is valid because the string that we get back from get item at position 0 will be copied into the string S, which is main. That's valid. So the string at position 0 on the heap for that array in our list will not be changed. That's fine. Another valid way to get the return value is to just save it as a const reference. So you can see here, we have a const string reference S, and we're storing the item that we get back from the list of position in that const reference. That's also acceptable. But you can see that if we just tried to store the return value from get item as a reference to string, it would not compile because it does not protect the string that is at position 0 in our grocery list on the heap. So that's why that will not compile. So we can see there's two objects that are not going to change. So the one object that we just discussed is our string at position 0 in our list. Okay, so that's one string that's not going to change. And that's the one object that's not going to change. The second object that's not going to change is our grocery list object. And our grocery list object is not going to change because of this const right here. And our string object is not going to change because of this const right here. So that's how the const keyword can be in two different ways. It can be used behind a member function in order to protect the object on which the function is called. And it can be used with a return value in order to protect the object that is going to be returned. Another way that we can use const is for input parameters. So here we have our merge function. So our merge function takes as its only parameter a const reference to a grocery list. What that means is that this merge function cannot change the grocery list that is input as a parameter to merge. And what does merge do? Merge takes the list that is given as a parameter and adds all of the items to the list that is calling it. So as we can see inside the implementation of merge, we first get the size of the input grocery list and save it as limit. Then we go through each item in the other list and add it to this object. That's the calling object. So just remember that the this pointer is a pointer to the object for which this member function is being called. So I like to refer to it as a self-referential pointer. And you'll notice that this merge function is not a const function, and that is intentional because we actually want to change the grocery list object on which this merge function is called. We want to actually add all the items from another list onto this grocery list. So you'll notice it's not a const function. The only place that we see const is in order to protect the list that we're passing as a parameter. So let's see what happens inside main now. So once again, we instantiate a grocery list, list 1. And we add the items apples, bananas, peaches to that. And then we instantiate another grocery list object, which is list 2, and we add onions, peppers, and broccoli to it. Then when we call list1.merge and we pass list 2, you'll notice that the const keyword protects list 2. List 2 is not changed as a result of a call to merge. Only list 1 is changed. So the list 1 object will then, after this merge, have all 6 items on the list, and the list 2 will just remain with the 3 items. So if you see the const keyword before an input parameter, that means that object will not be changed. And I just want to mention that some of the reason why you might pass an object by const reference, and remember the ampersand after the type means that it's a C++ reference variable. That means we will not copy it, and the const will protect the input parameter. So that's one very common use of const and C++ reference variables when you're passing parameters to functions. And you may see that, especially if this was a very large object, there would be great advantages of passing your input parameters by const reference rather than just copying